Welcome everybody to a new video on MathBusters. Today we will be exploring trig identities and diving deep into what a trig identity is and its various applications. Get some food, relax, and enjoy the video.
So, there are several types of trig identities. The first one we're going to talk about today is what's known as Pythagorean trig identities. So, these trig identities basically stem from the Pythagorean theorem. So let's just say we have a side A, a side B, and a hypotenuse C. Now, as we all know, a squared plus b squared is equal to c squared, right? But if we divide...
Why is a squared plus b squared equal to c squared?
Okay, we're going to have to... So let's have a square, okay? A square has equal sides on, like, all its four sides are equal, right?
Okay.
Now, what I will do is I will make four equal triangles and put those triangles inside the square. Okay?
Okay.
All of these triangles are the same. They're the exact same triangles. Now, since these triangles are the same, their hypotenuses make this inside square, right? Right?
Yeah.
So, I'll call this length A, this length B for each of the triangles. And as we know, each triangle is the exact same, right? Each of these four triangles.
Yeah.
So, what we can do, also I'll call this hypotenuse on the inside C for each of these right triangles. So we know is that A plus B squared is equal to, what's the area of this triangle? This
One
triangle.
half AB.
Yes, plus half AB. And how many triangles are there?
4.
Yes, 4 identical triangles. So A plus B squared minus half AB times 4 is equal to C squared, right? Or A squared plus 2AB squared, plus 2AB plus B squared minus half AB times 4 is 2AB is equal to C, or A squared plus B squared equals C squared. Does that make sense?
Oh, yeah, that makes sense.
So back to what I was saying. We have A squared plus B squared is equal to C squared. Now, if we divide them all by C squared, we get A over C squared plus B over C squared is equal to C over C squared, which is just 1, right?
Okay.
Now, if I have this angle, let's just say alpha, and this angle beta, what is the, or let's just keep it as alpha. What is A over C in terms of alpha?
No, the A over C is the cosine.
Yes, so we have cosine of alpha squared plus, what is B over C in terms of alpha?
Sine.
Sine of alpha squared is equal to 1, which is our first identity. Now, does that make sense?
Yeah, I see how you did the proportions and like how that got into cosine in terms of sine.
Now,
vice versa.
This identity, this Pythagorean identity, which I'll call our fundamental identity, we can use that to create other identities. So let's just say we divide it all by cosine squared alpha. So cosine squared alpha over cosine squared alpha is 1. Now what's sine squared alpha over cosine squared alpha?
Tan squared alpha.
Yes, tan squared alpha. And now what's 1 over cosine squared alpha?
Secant squared alpha.
Yes, secant squared alpha. So that's our second identity. 1 plus tangent squared alpha. The tangent of alpha squared is equal to the secant of alpha squared.
Mm-hmm.
Now we can use this. Now, what happens if we divide by sine?
We would get cotangent squared alpha.
Yes. Plus,
Is that a 1 sine alpha right there?
it would be plus 1, right? Because we're dividing it all by sine squared alpha. Cosine squared alpha plus sine squared alpha equals 1 all
Equals
by
1.
sine squared alpha.
Yeah, that makes sense.
And that would equal to cosecant squared of alpha. So what we have are these three trig identities, which are called the Pythagorean identities. Does it make sense on how we got all of these?
It's basically you used the Pythagorean theorem to find out the cosine squared x plus sine squared x, where x is alpha in this case, to equal 1, and you just use that to derive these other two, right?
Yes, exactly. Now,
Cool.
the other type we have are called you could say addition angle identities. So first thing we're going to do is we're going to see what sine A plus B is equal to. So I'll draw this diagram with two right triangles, and for each of these, and between each of these right triangles, I'm going to draw another right triangle. So we have the angle A, the angle B. We have one right triangle. We have our other taller right triangle with angle A plus B. And then we have this right triangle that connects this top point of the triangle of A with the angle A plus B, and this triangle with the angle of A. And then inside of that right triangle, I'll put another right triangle. So if I start labeling, I'll start labeling these points. I'll call this O, I'll call this let's just say P, T, Q, R, and S. So what is the sign of the angle of A plus B in this triangle POR?
It would be the length of PR over the length of OP.
Close. So it would be the length of PR over the length. Oh yeah, actually no, that is right. PR over OP. Yes, that is my bad. Anyways, we can rewrite PR as PT over OP plus TR over OP. And if you look at this, you'll see that TR is the exact same thing as QS, right?
Yeah, because it's the same length, yeah.
So PT over OP plus QS over OP is equal to the sign of A plus B. Now, what I can do is I can just say that is equal to PT over PQ times PQ over OP. And what does this equal?
It would just be
PT over PQ times PQ over OP. What does that equal?
it would just be PT over OP.
Yeah, exactly, which is that.
Mm-hmm.
We can do this exact same trick for QS over OP, rewriting it as QS over OQ times OQ over OP. Now, what I'll do is I'll start filling in some angles so that you can see how this is starting to come together. This is the angle A because TQ is parallel to OS. And this is also the angle A because remember, because this angle A it's in this right triangle, so okay. So this is angle A because this is a right triangle, right? This small triangle from here to here, here.
Yeah.
This being angle A means that this has to be 90 minus A, which means that this has to be A. Does that make sense?
Yeah, I got that. Yeah.
So what is PT over PQ in terms of angle A?
Cosine.
Yes, that is equal to the cosine of angle A. Now what is PQ over OP in terms of angle B?
Tangent.
Not tangents.
You said PQ over OQ, right?
PQ over OP.
Oh, that's sine. My bad.
Yes, so sine of angle B plus, now what is QS over OQ in terms of angle A?
QS over OQ would be, it's also sine.
Yes, so sine of A. And what is OQ over OP in terms of angle B?
Cosine.
Yes, that would be the cosine of angle B. And so what we have is that the sine of A plus B is equal to the cosine of A times the sine of angle B plus the sine of angle A times the cosine of angle B. Does that make sense?
Yeah, I just had a quick question here. So you see, if we look above, we see P over T, PT over OP plus QS over OP. It's on that right-hand side at the top right. So how do we get from that to like this sort of multiplicative expression, like PT over PQ times PQ over OP?
See, the way we can do that is because, as I asked before, PT over PQ times PQ over OP, the PQs cancel, right?
They do, yeah.
Which just leaves us with PT over OP.
Oh, yeah. So adding that extra term doesn't actually do anything because it just cancels out.
Yeah, it doesn't do anything, but it lets us simplify our identity like this. Now, we can use this same model for the cosine. So, what is the cosine of angle A plus B? The cosine of angle A plus B is OR over OP, right?
It is, yeah.
So, we can rewrite that as OS minus RS over OP. And now, you'll see that RS is the same thing as TQ, right?
Yeah, RS and TQ are the same.
So OS minus TQ over OP is again equal to cosine A plus B.
Mm-hmm.
I'll just split this apart. OS over OP minus TQ over OP. So now what we can do is we can just use that same old trick again that we used for sine. So we have OS over OP, right?
Mm-hmm.
So OS over something times something over OP. Now what should that something be? Well, if we look here, OS, we could just set it to OQ, right?
Why OQ though?
Because what's OS over OQ in terms of angle A?
Oh, it's the cosine.
Yes, we get the cosine and OQ and over OP in terms of angle B is the cosine of angle B. Now what we'll do is we'll just subtract that from TQ over something times something over OP. Now TQ, we could just set that to PQ, right? Because as we see in the diagram, TQ over PQ in terms of angle A is
Oh, also the cosine.
not the cosine, the
Or sorry,
sine.
that's the sine. Yeah, that's the sine.
So we can then simplify this as the cosine of angle A, as previously mentioned, OS over OQ times the cosine of angle B, OQ over OP minus the sine of angle A, which is TQ over PQ, times the sine of angle B, or PQ over OP. And we get that that is equal to the cosine of A plus B. Does that make sense?
Yeah, that makes sense. Yeah.
Now, if we want, we can try to find what tangent A plus B should be. Now, what is tangent in terms of sine and cosine?
Sine over cosine.
Yes. So, do you understand why?
No, I don't understand the reasoning behind it. It's just a simple thing we learned as part of trig.
So, let's take our triangle, right? This triangle over here with sides A, B, and C. So tangent is B over A, right?
Yeah, opposite over adjacent.
Which could equal to B over something times something over A, right? Now, what should the something be? We could set it to C, and it will cancel out, give us B over A, right?
Yeah, it will, yeah.
Now I'll rewrite this as B over C times 1 over A over C. Now, what is B over C?
Okay. B over C is the sine.
Yes, it is the sine of our angle alpha. And what is A over C?
Cosine.
Which is equal to the sine of alpha over the cosine of alpha.
That makes sense.
And what is B over A?
B over A is the tangent.
Does that make sense?
Yeah.
So, going back to our problem, we have the tangent of A plus B is equal to the sine of A plus B over the cosine of A plus B. We can use the things that we've recently discovered. So, we have the sine of A times the cosine of B plus the cosine of A plus the sine of B. I'm just rearranging terms a bit. Over the cosine of A times the cosine of B minus the sine of A times the sine of B. Now, what we can do is we can just multiply everything by... We can multiply both the numerator and the denominator by 1 over cosine A cosine B.
What does that do?
What that does, the numerator and the denominator are the same in this fraction, right? 1 over cosine A cosine B over 1 over cosine A cosine B, right?
Yeah.
If I simplify this, we get sine A cosine B plus cosine A sine B all over cosine A cosine B. You see on how some of these terms would cancel if we split this apart, right?
Oh, and this is only for the numerator, right? We still have to consider the cosine A plus B on the bottom.
Well, that's even better. See, we have cosine A cosine B minus sine A sine b all over cosine A cosine B, right?
Okay.
This all cancels out to 1.
So how does
So,
it cancel out to 1?
because it's cosine A cosine B over cosine A cosine B, this part would cancel out
that
to
part
1,
cancels out to 1.
right?
Yeah.
And this part, it's just sine A over cosine A times sine B over cosine B, right?
It is, yeah.
Which is just tangent A tangent B. So, I'll just split this apart over, so sine A cosine B over cosine A cosine B plus cosine A sine B over cosine A cosine B. As I said, these cosines cancel out. The cosine B in the first part cancels out with the numerator. The cosine A in the second part cancels out with its numerator over cosine A cosine B over cosine A cosine B. This all cancels out to be 1 minus sine A sine B over cosine A cosine B. Now, if you look at the numerator, we have sine A over cosine A. What is that equal to?
Tangent of A.
Yeah, tangent A plus sine B over cosine B. What is that equal to?
Tangent B.
Over 1 minus,
Tangent
I'll
A
split
times
this.
tangent B.
But yeah, we have sine A over cosine A, which is tangent A times what sine B over cosine B, which is tangent of B. Make sense?
And this formula would be for the tangent of A plus B, right? Because we're taking sine A plus
Correct.
B over cosine A plus B.
This is equal to the tangent of A plus B.
Cool.
Now, what we can do is we can use these simple addition identities to get double angle identities. So, the sine of 2 theta would equal to the sine of theta times the cosine of theta plus the cosine of theta plus the sine of theta, right?
Because you're saying sine cos theta plus theta, A plus B.
Yeah, because 2 theta is equal to theta plus theta, which that's just equal to 2 sine theta cosine theta, right? Right?
Okay. Yeah.
Now, cosine of 2 theta, we said we can just rewrite this as theta plus theta, and we said that cosine theta plus theta is equal to cosine theta times cosine theta minus sine theta times sine theta, which is equal to cosine squared theta minus sine squared theta. Make sense?
Yeah.
And finally, tangent 2 theta, we just plug it in. That's equal to tangent theta plus tangent theta over 1 minus tangent theta times tangent theta,
So 2
which that is
theta.
equal to 2 times the tangent of theta over 1 minus the tangent of theta squared. Does that make sense?
Yeah, but one overarching question. So I know the cosine 2 theta also has 2 more identities. How else would you solve? How would you derive those?
Well, do you remember on how cosine squared theta plus sine squared theta is equal to 1? So, since we know that, we can just subtract cosine theta from both sides, getting sine squared theta is equal to 1 minus cosine theta.
Oh, and that's where you get the 1 minus 2 cosine theta because you just plug that in.
You would just plug that in. Cosine squared theta minus 1 minus cosine squared theta,
And you get 1
which is
minus
equal to
theta.
2 cosine squared theta minus 1. And for
Yeah.
the other one, you just say cosine squared theta is equal to 1 minus sine squared theta. Plug that in. 1 minus sine squared theta minus sine squared theta
1
is
minus
equal to
2
2
sine.
cosine theta, which is equal to 1 minus 2 sine squared theta. Does that make sense?
Yeah.
All right, that's all I have for you today.
Cool. Thank you, everybody, for watching this episode of Math Busters. I hope you enjoyed. Don't forget to like and subscribe and comment any feedback below. Thank you for watching, and we hope to see you in the next episode.